Hello, my name is Pranav Lohia, and this is my final submission for my Engineering 1050 final project. This is my video submission, and in this, I will try and explain what my project does. My project is called Averaging Heat Maps and Player Performance. Um, for this project, I have looked into the soccer world and looked at how Messi, in his most recent World Championship, which is the FIFA World Cup, performed over 5 matches and 10 matches, and as many number of matches. And I tried to create an average heat map of his FIFA World Cup season this time. So in order to get the heat maps for the FIFA World Cup, I went to a website called SofaScore. I went to World Championships, and I clicked on the ratings for each of the matches. And after I click on the rating, I get a sort of a heat map of for the player. So a heat map essentially is a positional density matrix, which tells me where there is red, it means that there is high probability of the player being there at high positional density, and where it's yellow, it means that the player was present over there but not for very long. Green essentially resembles the pitch and does not show that it shows that the player was not there for too long. In this code, I screenshot this image because I cannot import it, and then my code essentially once I run my code, so I run my start function and after I run my start function, I can average 5 heat maps. So let's just say I average 5 heat maps. So I run the functions, and after I run it, it makes me prompt the match rating. So I enter multiple match ratings. So these are the match ratings for each of the matches, and 0.6. So after I enter the matches for each of the matches, and after I enter the heat maps, I get a sort of a average heat map, and as you can see, it shows me what the preferable position for Messi was in these matches, and what the average rating of these matches was. And this says that it's an average rating of 8.5, which is very good. That means that Messi should ideally be playing left wing or right wing or center forward positions. For this code, I've used 5 functions, which is corner one, corner two, corner three, corner four, to identify the corners of my screenshot. I then crop my image using the IM crop function, and then I resize my image to the standard dimensions of a football, which is 180 by 240. I then try and find the position density using position density function, which I've created, and I set up my own color map by using data tips from the inbuilt MATLAB toolbox. After I use data types on my inbuilt MATLAB toolbox, I build a color map of 100 values, and then I compare each of the data after reshaping my original resized matrix. And after comparing them, I get a double matrix by 180 by 240, which essentially tells me where my indices, what my position density was. And so for my final code, I use the UI get file function. I select multi-select, and then then I store the files. I use a set. I initialize a empty zeros matrix, and then I average that to find the average match rating. I then convert that average match rating into a color matrix by remapping the CMAP values. And after I remap the CMAP values, I then find the average match rating by prompting the user multiple times to enter the match ratings. I then enhance all of the red values, which is the high probability density areas, and then display an image, and also display the positions using which circles after identifying which position the player should be playing in. I also give an average heat map rating, which helps me achieve that. It tells me where the position of the player was if it played a good match, and where it was if it played a bad match. That is about it for my code. Thank you so much.